Thank you for giving me an opportunity to talk today about carbon removal, which is a climate technology that, if successfully scaled and paired with steep emission reductions, can help us avoid the worst impacts of climate change. I want to share today how technology being developed right here on the University of Washington is helping us meet this pressing need for carbon removal technology. And I want to share a little bit about the journey that my co-founder and I have been on to become faculty entrepreneurs. So my primary role at the University of Washington is as faculty in oceanography, where for the past decade, like other faculty, I've been focused on teaching and leading a research group and supporting and serving the community. As a chemist and oceanographer, I focus on how the connections between carbon dioxide and ocean chemistry and climate. We study how the past ocean is related to past climate so we can better predict the climate of the future. And we get to work with really cool tools, from mass spectrometers to submarines, from numerical methods and machine learning to aquariums. And we get to go to some pretty cool places, pretty warm places too, which is relevant this time of year. I feel exceptionally lucky to be part of the University of Washington School of Oceanography. And in the Pacific Northwest, I feel like we tend to be overly modest. And I'm trying to work on this, especially for things that matter. And this matters. The School of Oceanography here at the University of Washington has been ranked the #1 or #2 program in oceanography in the world for the last 7 years in a row. And that's pretty impressive. And I'd be the first to sort of say that some rankings are a little bit subjective and don't capture the complete picture. But what I can say with conviction is that these rankings and other accolades really represent the incredible students we have at the University of Washington, the creativity and transformative science that my colleagues make, and the relevance of our mission. And there's no need to be modest about that. We have some of the best programs in the world in oceanography, in atmospheric and climate science, in fisheries, in earth science, and other environmental programs right here in the College of the Environment at the University of Washington. And in the simplest of terms, what this cutting-edge research is doing is trying to figure out how the world works. In a time of big changes to the Earth and to climate, it's exceptionally important to have these fundamental insights into how the world works so that we can predict and plan for climate change, so that we can adapt and mitigate, so that we can come up with climate solutions, and really importantly, evaluate the impact of those climate solutions and the effectiveness of those solutions. Lasting and equitable change and equitable solutions have to be based on a true fundamental understanding of how the world works. Reality matters. And importantly, this fundamental work can also be the sparks of innovative new approaches to solve these problems. And I want to share an example from my own research and from research of colleagues. So during research that we were conducting in the tropical Pacific, designed to measure the impacts of ocean acidification on coral reefs, my co-founder, Professor Julian Sachs, and I were challenged to engineer an experimental system that could pull carbon dioxide in and out of water on a reef. And this was work that was supported by a private gift from the Seeley family, a longtime friend and supporter of the University of Washington. And so we had both scientific purposes that we were working on, but we also were trying to build an innovative engineering apparatus that could help us to do this, because we were moving carbon dioxide in and out of water to make these tests on a reef at a much larger scale than you would typically do. And importantly, on an island, energy is really precious. And so we were having to do this in a really low energy way. And so, inspired in part by this work, we came up with a really efficient way to pull carbon dioxide in and out of water. It turns out that the same constraints and the same sort of scientific challenges that you had to do to be able to do this work on an island help prepare us to sort of think and engage with the challenges that you have to do to scale up carbon removal at a global scale and to make it commercially viable. And developing carbon removal techniques are so important because every viable plan to keep global temperatures below dangerous limits right now involves not only steep emission reductions, but also a billion to billions of tons of carbon dioxide removal per year starting in the 2030s. And there's a pretty big gap between that pressing need for carbon removal and existing solutions. Existing solutions, there's been an incredible amount of creativity and work in this space, especially recently, but existing solutions are costly, energy intensive, and importantly, they're about 10,000 times, if you sum up the amount of global capacity right now, they're at least 10,000 times short of where we need to be. So this is an incredible technical challenge, an incredible scaling challenge. So recognizing this challenge and inspired by our work on tropical reefs, it's a great place to get good ideas, my co-founder and I have been developing new carbon removal technology. At Banyu Carbon, we're developing a simple, energy-efficient process for removing carbon dioxide from seawater that's powered by sunlight. We use a photochemical reaction to extract carbon dioxide from seawater. The sunlight-triggered molecule, small organic molecule at the heart of our process, that's called a reversible photoacid, is kept separate from seawater. It doesn't involve rare earth elements or toxic metals or any metals for that case, and it can be used over and over again. And so using this light-triggered molecule that pushes carbon dioxide into and out of water, depending upon its illumination, we built a process to extract carbon dioxide and turn it into an easily measured stream of gas. And then this carbon dioxide that's extracted can either be geologically sequestered, permanently removed from the climate system, or used as a feedstock for green chemistry. And in fact, one of our investors is a major airline because the carbon dioxide that we hope to produce at scale is one of the major feedstocks that needs to go in for making synthetic fuels that, if properly scaled, could help decarbonize long-haul flights. So in the simplest of terms, our process takes carbon dioxide-rich water that's absorbed a lot of the emissions of carbon dioxide from the atmosphere, naturally does that, takes that as an input and uses sunlight and extracts carbon dioxide, and then produces a decarbonized low carbon dioxide stream of water that can be returned back to the ocean, where it then can pull more carbon dioxide from the atmosphere. Importantly, we don't add anything to water. We're just removing carbon dioxide, the root cause of climate change, and helping humans clean up after our mess. So my co-founder and I, after experiments we'd done in the lab and a bunch of modeling, were excited about this new process. We wanted to take it out of the lab, scale up and bring it to market, but we didn't have a whole lot of experience with this. So supported by CoMotion, UW's commercialization program, and with the gracious support of UW leadership, we formed a company 3 years ago. It's been a steep learning curve, but since then we've raised $8.5 million in investments and secured a first set of customers through a pre-purchase contract for carbon removal that's supported by a consortia of major tech companies. And a few weeks ago, we were even on the front page of the Seattle Times. Our company is located right here in CoMotion Labs. That's just in Fluke Hall. And while we're still a pretty modest-sized startup, we're only 9 people right now. We've doubled our size in the last 6 months, and we're hoping to continue to grow. And we're creating high-quality jobs right here in Washington State to help tackle real global problems. So we have a simple, low-energy approach for carbon removal, and we have a ton of momentum, and I'm super excited about the contributions that we can make to slow climate change. But I don't want to make it sound like, the challenge of carbon removal or climate change has been completely solved. The scales that we and other people trying to do carbon removal have to get to are really large. This is a challenge like doing the Apollo Moonshot program at the same time as the Interstate Highway program, because we have to develop new technologies at a really rapid scale and deploy them widely very quickly. And importantly, unlike the highway infrastructure of the 1950s, we need to do this in a way that supports communities rather than divides them, where the communities that are most impacted by climate change can feel the benefits of new technologies like this. And there can be real benefits. If carbon removal is scaled to the scale that it needs to be to have a climate impact, it's projected to result in $100 billion to $1 trillion per year new market that could really drive economic growth. And the US, and especially Washington, are really well positioned to become leaders in this new field. Indeed, while carbon removal is a global challenge, it's also a Washington story on both sides of the Cascades. Carbon technology startups from around the world are flocking to Washington, from Sequim to Moses Lake. And this is because of a really incredible combination of some of the greenest electricity in the world, together with an incredibly well-educated workforce and really promising opportunities for storage throughout the state. Also some of the biggest names and major buyers in carbon removal, either headquartered in Washington or have major operations like Microsoft, Amazon, and Boeing. Washington is also a major leader, the world leader in marine approaches to carbon dioxide. Companies like ours and a host of others, together with the University of Washington and our really important partners at federal labs like NOAA and the Department of Energy, make our region a center of excellence for understanding the connections between climate, the ocean, and carbon. And this is no accident. Washington State's leadership in recognizing the problem of ocean acidification and trying to develop solutions to address this problem built a level of scientific excellence and a trained workforce that's focused on marine carbon that's unparalleled in the world. And that is directly translated to our leadership in marine carbon. Carbon removal is a global problem with a Washington solution. So I'm really extremely excited about the role that Washington, that the state and the University of Washington can play in innovating, evaluating, and deploying carbon removal and other climate technologies. And I also hope that I was able to share a story today about taking science out of the lab and into the market, and how this journey really fits squarely within the university's mission of innovation and impact, and how it's one more way that universities can have a really important and high impact, positive impact on communities and on our planet.